In this video, we are going to talk about the numbers in Python. The numbers are actually very much important in any programming language. Why? Because it deals with the numbers data type. For example, whether you want to do any types of computations in any programming language, you actually need to know how to deal with the numbers. So we are going to learn about the basic things about the numbers in Python now. So first, let us create a Python file. I would just use the command line to create this, and I would say video 5.py. Okay, you can also create this from here, but just click over this and just name with .py extension and it will be created. So now let us start. First is that integer. So integers are actually represented with the help of int. Actually, you do not need to explicitly mention that a variable is actually of integer data type. You just need to figure out that it is an integer by just seeing it, or by performing the operations and output in the variable. So for example, how the numbers are represented, for example, n equals to 5 or m equals to 9, etc. So these are actually numbers data type. Why? Because 5 and 9 are actually integer data type. Why? Because you cannot see any decimal and these are numbers. So how will you know that this is a integer data type? You can use the type method, type of n. So if you run this command, you would see class int, which means that it is an integer data type. Again, if you want to check the type of m, also you will get the same result, that is integer. Next is the float. What is float? Float will consist of the decimal points, for example 5.7, minus 8.9, 0.0, etc. These are actually floating point numbers. For example, if you say n equals to 440.34, so you will see here it is a floating point number. Next, if you just add minus over this one also, it will be a floating point number. Why? Because it consists of a decimal. Floating point number consists of all the numbers which contains the decimal. The next is the complex numbers. Complex numbers are actually those numbers which contains real part as well as the imaginary part. For example, so typically what is the you know uh, body of the complex numbers. So usually it looks like this one: a plus b j. uh, I think you have guessed right that mostly in the mathematics we use something like a plus bi, but in Python we use a plus bj. Why j? Because in circuitous system we mostly use the I. So for more convenience and for some difficulties in implementation, usually we represent it with the j. Actually, it is must to represent with j in Python. So for example, you just declare 4 plus 9.4 and j. Okay, so you just want to see what is the data type now. So you will see it is a complex number. Okay, so now we're done with most of the basic. Okay, again, you can just see this is still a complex number. Okay, again, if you just write something like this is still a complex number. Why? Because it contains a j and j. Typically this is equivalent to this. I mean, if you just go for the value, this is actually almost equal to this. Its value is almost equal to this, but still it is a complex number. Why? Because it has the imaginary component which is 0. Next, we are going to find out about the basic operations which you can perform. So first is the addition. It is pretty much easy. For example, if you just say that n equals to 14 and m equals to 23, and you just want to print what is the addition. So n plus m. So what it will be printed? 37. Addition operation is performed. Similarly, if you want to perform the uh, subtraction operations, again you can do it like this one. So just put the subtraction symbol and then subtraction is performed. And it doesn't mean that it should contain only integer. It can be anything. Like for example, it can contain, say, complex number and integer, so like this. So again, Python will internally do the type conversion, and if something is complex number, again this will be converted into complex number, and then the operation will be performed. And even if you do something like this, that is, it is a complex number and it is a floating point number, again, some and this type of result will be obtained. Okay, one thing it should be noted is that the biggest of all the numbers should be complex number. Subdomain of this complex number is the floating point number, and the subdomain of the floating point number are the integers. Why? For example, 4.4 plus 2j. This is a complex number, right? Let's say 4 point, this one. This is a complex number, right? Is it a floating point number? No. Is it an integer? No. But suppose you say this. This is an integer. Yes. Yes. Is it a floating point number also? Yes, obviously it is also a floating point number. But if you just print the type, it will show integer. But it is also a floating point number, obviously, according to the logic of mathematics. And is it a complex number? Yes, it is obviously a complex number, because you can represent this as uh, 0, 4 plus 0 j. But in mathematics this is possible, but in Python the type of 4 is obviously kept as integer. You got my point, right? Next is multiplication and division. For example, again, I will just take this one, and you want to multiply. Print n into m. You want to check the result. You would see something, multiplication is done. Why this output is somewhat not exactly what we want, we'll be checking later on. Okay, I would just explain why. N equals to 0, m equals to, let us go with the smaller integers, and let us say that this is n equals to 5, and it should be 45. Okay, see, 45 is the result. And if you want to just do the subtract, division, the division is performed by this operator. And if you want to go for division, it will again go for 0. uh, why is it so? Why is it so? Why the precision is like what the result should be? It should be 0, 0.4545, it's something like this, but 0 is printed. Why? Because the output is now in the form of integer. Both are integers, so that's why the output should be in the form of integer. Now if you do something like this one, see, again 0 0.0. And now this division is giving the result 0.5555 and 6, like this. So this is the division operator. And this one, what does this say? This is actually the uh, float division. Okay, so this actually gives the floor value after the division. Next is the modulus. So what does modulus means? Modulus is actually the remainder which you obtained after dividing with a particular number. For example, suppose, and it is actually represented by this percentage sign. Suppose 5 modulus 2. So after dividing 5 by 2, what the result you will be getting? You would be getting 1. So this is the result of the modulus. Okay. So print n modulo m. So what it should print? Let's say this is 25. So 9 twos are 18, and what is the remainder? 7. So it should print 7. See, it is printing 7.0. And why it is printing 7.0? Because one of the numbers is floating point number. What is the whatever is the biggest precision, that will be printed. If I just remove this one, so it will be in the form of integer. See, integer. Next is the exponent. What is exponent? That is exponential. Like for example, 5 to the power 2 means what? 5 into 5. 5 to the power 3 means what? 5 into 5 into 5. So you can use like this. N, uh, like 5 to the power 4. I want to print 5 to the power 4. First is the base, and next and then, and this is the exponent. So The result is 625. Suppose I want to go for 6 6 to the power 4. So the result should be something like this. Next, I would like to explain this one. That is, suppose suppose 3.0 minus 2.0. 2.0. You want to print this. Okay. Let us suppose you want to print this. It is 1.0. Okay. Let us change it a little bit. It is 1.1. Okay. All right. But let us change this to something in a different way, because you will be getting a weird result now. Let us see. Okay. Still, this is 3.1 minus 2. So 1.1 is the result. All right, all right, all right. So let us take the addition. Okay. Still this is 5 point still this is 5.1. Great. Now suppose I change this value to 2.2. So what do see what the result what was the expected result? The expected result was 3.3, but what do you get in terms? This one. So why this fraction has came, and isn't this an error? So actually the error didn't come from Python. Why the error was present? The error was present because the system actually have to do a lot of stuffs for the calculation. And like for example, to represent the point 2, point 3, etc., it there the number should be something like this. For example, like point 2 should be represented infinitely like this, and it is not possible to infinitely represent by the system. So always there are some form of error, and due to that error, this error is actually given in the form of output. This is not an error from the Python alone. This is actually error from the system only. So that's all for today. Hope you got to know something good, and let me know in the comment section if you have any doubt.